Hey everybody, this is a video on naming different compounds in chemistry. I don't want to say binary because we have some polyatomics that we're going to be working with also, but just very basic chemical compounds that you would encounter in your general chemistry courses. If you're watching this and you're in AP chemistry, I do want to tell you just a couple of different things that are going to be useful kind of as you're progressing through naming. The first is that on your AP exam, you will not have the periodic table that I give to you that has all of those different charges on it. So you will have to become very comfortable with the charges of the elements. And I'll show you very briefly how you can determine, especially just ones that monatomic ions, one that have just one charge that are applied to them. But some of your transition metals might have more than one charge. And I think you'll get pretty familiar with these just kind of as you're working with them. You don't have to memorize them, that's not what I'm saying, but just start to become familiar with what transition metals have one charge and what transition metals have more than one charge. So just be aware of that. You'll also need to know the different polyatomic ions by heart. You won't have to know all of them because I promise you I don't even know all of them. But the very basic ones that you'll see and that I think you'll just learn by seeing them so much and memorizing them are like your nitrates, your sulfates, your hydroxides, your bicarbonates or carbonates, phosphates, for example. So you'll learn those just by seeing them so much. If you're in Chem 2 or if you're just in Chem 1 and you need a little bit of a refresher, you are more than welcome to use the periodic table that I give to you, the polyatomic ions, the monatomic ions, whatever you need. But this kind of shows you how to name without using the flowchart, which I think is really convenient to know how to do because it's kind of annoying to have to look at the flowchart all the time. And really, naming isn't all too difficult. So I'll try my best to break it down for you. I guess let's just dive in and let's get started. So this right here is a really nice periodic table that I found online, and the reason why I like it so much is because you actually have elements 113 to 118 with their correct and updated symbols. So you have nihonium, flerovium, moscovium, and all of that. I find it very difficult to find updated periodic tables like this that are in just black and white. So I'm really happy I found this one. And it's on some website where you could buy it, I think. So just kind of excuse all this stuff here at the top. When you're looking at a periodic table, it's actually quite easy to know what the charge is going to be for a lot of the elements, especially your main group elements. So that's this whole section right here and this whole section on the other side. The transition metals we'll talk about in a little bit. Hydrogen and the rest of the alkali metals, well, hydrogen technically is not an alkali metal, so hydrogen and the alkali metals all in group 1 in a binary compound, which means it has just two elements that make it up. You have a metal and a non-metal. These guys will all have a charge of positive 1. No exceptions to that rule. There's reasons why they all have a positive 1 charge, but we're not going to go into that right now. Your alkaline earth metals, so everything in group 2, these guys will all have a charge of positive 2. So pretty easy so far. These guys only have 1 charge, and they're either +1 or +2. Like I said, we're going to skip the transition metals. Right here, group 13, so borons group. Everything in this section in a binary compound will have a charge of positive 3. Not too bad. Carbons group, so group 14. Now, if you think back to valence electrons and electron configuration, these guys have 4 valence electrons, and to become stable, they're going to want to either lose those 4 electrons or they're going to want to gain, and it depends on what else it's bonded to. That determines whether it's positive or negative. So in this case, carbon's group, I should say, will have a or -4. It depends what else it's bonded to. If carbon is bonded to something positive like hydrogen, it's going to have a -4 charge. If carbon is bonded to something negative like a halogen, it'll have a +4 charge. So it just depends. Nitrogen's group 15, these guys will have a -3 charge. In a binary compound, so in AP chemistry, we're going to talk about formal charges. Nitrogen's not always -3, which is why that periodic table that I give to in Chem 1 and Chem 2 has a lot of charges for some of the elements, especially your halogens, like chlorine, I think, has a ton of them. Because when it's not a binary compound, it could have multiple charges. We're just focusing now on when it is binary. Oxygen's group is -2. So everything in this group will have a -2 charge. Your halogens here all have a -1 charge. And your noble gases all do not have a charge. So these guys are just neutral. And that's because they're already stable. They already have a full outer shell of electrons, so they're happy the way that they are. Most of your transition metals here in this section are going to have multiple charges. However, there's a couple that I can think of off the top of my head that have only one. One of those is zinc. And zinc only has one charge, and that one charge is +2. Another one that only has one charge, that's silver. Silver's only charge, just put an arrow here, is +1. A lot of these other ones you'll see have more than one charge. And like I said, you don't have to memorize them, but just recognize that they have more than one charge. Now that we've done all of this together, let's go ahead and do some examples. Something else I should tell you that's really important is how to determine where your metals and nonmetals are located. And the way I always remember where they're located is because there's the staircase in the periodic table. Most periodic tables are not going to have the staircase drawn out for you specifically, but it's really easy to know where it goes. You always start on the outside of boron. That's going to be the first, where the first step goes, let's say. And literally, you staircase going down. But you always want to start off on the outside of boron. I think my image there is kind of going towards that, but that's okay. So that's the staircase. Everything to the left of the staircase are your metals. That's very important to know. And like I said before, some of your metals have only one charge, like your alkali metals and your alkaline earth metals and the couple of transition metals. The other ones have more than one charge. On the other side of the staircase, these are your nonmetals. I don't know why I did that other one in all caps, but that's okay. It's very difficult to write with a mouse, but we'll get things done. All of these are nonmetals. That's also very important to know. There's a couple of metalloids kind of around this staircase, but we really don't need to know which specific ones of those are in fact metalloids. The biggest thing is your metals on the left side and the nonmetals on the right side. Just beware, hydrogen technically isn't a metal, but hydrogen always does its own thing. So just remember that hydrogen never fits in. So even though it's on the metal side, it's not actually a metal. Let's go ahead and get into some naming. So in your general chemistry classes, there's really three very basic types of compounds that you should know how to name very, very well. And I'm going to go over each of those three with you. The first type of compound is an ionic compound. And if you remember, an ionic compound is when you have a metal that's bonded to a nonmetal. However, the periodic table does have a couple different types of metals, and like we talked about before, some metals have more than one charge and other metals have only one charge. And the first type that I'm going to show you how to do is when your metal has only one charge. The These are very easy to name. Let's just do some examples. So the first one we'll do is CaBr2. When you name something like this, you just want to say the name of the metal. So in this case, your metal is calcium, and your metal is always going to be listed first in your formula. And then you just say the name of your nonmetal. However, you want to change the ending so it ends with IDE. So in this case, the name of this compound would just be calcium bromide. You don't have to do anything with any numbers. You just leave it exactly the way it is. You just say the name of your metal and then say the name of your nonmetal ending with "ide." That's it for this one. Let's do another one. The only thing is we have a polyatomic ion with this. So here's Ag2SO4. Ag is silver, and that is one of your transition metals that does only have one charge. And the charge for silver is always going to be +1. Chem 1 and Chem 2, you can always look this up on your chart. AP chemistry, that's something I would definitely remember, that silver only has one charge of +1. So when we're naming this, we don't have to say any numbers to go along with this because silver is always 1. So I just say the name of the metal, which is silver. And here I have a polyatomic ion, and my polyatomic ion is this guy right here. Chem 1 and Chem 2, you are more than welcome to look this up. AP chemistry, you should be able to identify what SO4 is, and that is your sulfate polyatomic ion group. So notice I didn't change the ending here. The only time you do want to change the ending is when you have just a binary compound. So binary meaning two elements that make it up. Sometimes you're not going to have binary compounds. You just want to say the name of your polyatomic ion. So in this case, it is silver sulfate. Not too bad. You just want to name them, say the name of the metal, say the name of the nonmetal, changing the ending as needed. Let's try the second basic type of compound. So in this case, it's also going to be ionic, which again is a metal bonded to a nonmetal. But here, your metal is going to have multiple charges, which is going to be most of your transition metals. Not all of them, but most of them. When we're naming an ionic compound with a metal that has multiple charges, you do have to say what the charge is. So here, you do want to use Roman numerals. So I'll just put a little Roman numerals needed. Let's do a couple of examples with this one. So here's Cu2S. So your metal in this case is copper. You still have to identify what each of the elements are, so I'm just going to write copper down. And copper has two possible charges, and if you look on a periodic table, you'll see that its options are either +1 or +2. Now, if you're in AP chemistry, if you know that copper has multiple charges, you can identify what the charge is just by looking at sulfur, because I can see that there's no subscript there, which means that copper's charge must be +1. I think for Chem 1 and Chem 2 students, it is a little bit easier to know what the charges are and then identify it, but you could definitely see what the charge is just by looking at the opposite ion. And just knowing that copper does have more than one charge. So that 2 doesn't mean anything to us at that point. So you would need a Roman numeral, 1, next to copper, and then change the anion to end with "ide," or your nonmetal. And in this case, you would change sulfur to sulfide. That's the only number you need with this. That 2 is not necessary for naming because that 2 is sulfur's charge. And in a binary compound, sulfur's charge is always going to be 2. So you don't have to say anything for that. You're only naming you're only identifying the charge for the metal that has multiple charges. So in this case, the name of this compound is copper 1 sulfide. I'm going to link below my video to how to write formulas. I would do it in here, but I don't want to make this video too long. I want to keep them as short as possible. Here's another example. So gold is a transition metal that does have more than one charge. So before anything, we have to identify that it's gold. We do have another polyatomic ion in here, and I'm throwing some of these in just to do some practice with them. So there's PO4, which is the phosphate polyatomic ion group. If you're in Chem 1 or 2, you can look up the charge for phosphate and see that it's going to be -3. That's important because if you look up gold's possible charges, it's either a +1 or a +3. Now, if you're in Chem 1 or 2, you could see, okay, well, those are the options and you could figure it out. However, if you're in AP and you're not given those options, you could say, well, if phosphate is 3, there'd have to be a 3 down there, which means that gold must also be 3 because there's no subscript after the gold. So your charge must have to be +3 because in ionic compounds, remember, those, if they're the same or if they're divisible by the same number, they could be reduced. So this guy would be gold 3, and then we just identify the polyatomic ion, which is phosphate. So there are 2 examples for how to name with metals that have more than one charge. You do need to say what the charge is. Now, sometimes you might not have an ionic compound at all. You might have molecular compounds. And molecular is when you have a nonmetal bonded to another nonmetal. And when you do this, you do need to use prefixes. Students love to go prefix crazy. And you don't need to use them unless your compound is molecular. So I'm not going to have the prefixes listed, but on the flow chart and on on the flow chart they should be listed there. But if you're an AP, you should be familiar with the prefixes. Let's go ahead and try this one here. So Ci4. Notice that both of these are nonmetals. And again, you do have to know where your nonmetals are located by looking at what's on the right side of the staircase. For your first ion in this formula, if there's only one of them, you don't have to put the prefix mono in there. You just want to say carbon or whatever that element is. You only want to use mono if it is your anion, if there's only one of your second nonmetal. And I have 4 iodines. So the prefix for 4 is tetra. And then, just like I would before, I would change the name of the ending to end with IDE. So the name of this compound is carbon tetraiodide. Carbon tetraiodide. No switching of charges. You don't have to do any of that. The reason why is because in molecular compounds, they are not always going to have the charges that I showed you on the periodic table, which is why we always want to use prefixes for them. When you have binary ionic compounds, that's when you're going to use like your alkali metals are +1 and your halogens are always -1. Halogens, though, in molecular compounds are not always -1, which is why we do have to use prefixes for these. Let's try one more. So I have P5S3. I also have 2 nonmetals here. However, for phosphorus, in this case my cation, we have 5 phosphorus atoms. So we do want to use the prefix for 5 in front of phosphorus. So I would say pentaphosphorus. Notice I didn't change the ending there. It's just pentaphosphorus. And there are 3 sulfurs. So the prefix for 3 is tri. and then I would change the ending so it also ends in IDE. Pentaphosphorus trisulfide. Again, you don't have to switch any charges for these, or these don't switch. They strictly belong with the element that they're the subscript for. Pentaphosphorus trisulfide. So there's your two examples for molecular compounds. Now, as I've taught naming, I did find that there are a couple of exceptions to those three kind of basic ways to name chemical compounds. And the first exception is when you have ammonium as your cation. So if you just look at that formula, ammonium doesn't have a metal in it. However, you still want to name this as if it was an ionic compound. The reason why is because when this is in water, technically this is going to dissociate as if it was ionic. So it kind of acts ionic in a way, even though it's not if you look at the formula here. So when you have ammonium as a cation, you still want to name this by just saying the name of the cation. So here's an example. In this case, I have NH4. You always just want to identify that, which is ammonium. And then you also have that second polyatomic ion. So you would then name that guy there. So the name of this compound is ammonium nitrate. That's one exception. A lot of times people will look at this and they'll say, oh, well, it has to be molecular because it's made up of all nonmetals. Not necessarily. Ammonium acts as an ionic compound, or ammonium compounds will act ionic because they dissolve very, very easily, or rather they dissociate very, very easily. The second exception that I found is when you have hydrogen as a cation. Cation is the element that's listed first in the formula. So for example, if I have HCl. Now looking at this, again, this looks molecular, which it is, but it's the same thing with ammonium. This actually dissolves very easily in water, so this is going to break apart. When you're naming something like this, you don't say hydrogen monochloride. You're not going to name this using prefixes. There's really two ways to name something that has hydrogen in the front, especially if it's a strong acid like this one. You can either name this just by saying the names of both the elements, so hydrogen chloride. Again, notice I'm not using the mono prefix there because you don't have to, because technically it doesn't act molecular even though it is. Hydrogen chloride, or the way you can name acids in particular is we could use the prefix hydro for hydrogen, and then we would change the ending for chlorine, not so it's I, but so we put the ending ic, hydrochloric, and then you throw the word acid at the end of that. And that's true for any type of acid or anything that begins with a hydrogen in the front, a binary compound, I should say. So here, if this was a Br, it would be either hydrogen bromide or hydrobromic acid. Neither one of those is more correct than the other. Both of them are equally good. Those are really the only two exceptions that I've encountered when I was naming and students would ask me questions on them. So just keep those in mind as you're naming. Other than that, let me know if you have any questions, but those are really the three basic ways on how to name compounds in your general chemistry class. Thanks a lot for watching.